is there anything from your decades of experience in computational biology that you've brought into the University of Virginia School of Data Science? Are there any relationships there?
Yeah, if I think back, you say decades. Of course, people aren't going to be able to see me, but it's actually 4 decades, right? And I think what's in a way what's happening in computational biology is a precursor to what's happening in everything, whether it be religious studies or whether it be history, whether it be economics. It's the same. It's the same process. And so, by looking at that process in computational biology, which I'll explain to you, I think you can see where it comes from. So, when I was started doing this, well, it was late 70s, but let's just call it the 80s. I mean, the idea of using computers to study biology there was just basically a few of us that were weird, considered weird by the mainstream. um, and and then what really changed it all was the Human Genome Project. So the Human Genome Project that came along in the 90s, well, basically what happened there is that NIH, National Institute of Health, did a lot of things I could say about them. But one good thing I'd say right now is that they had the foresight to say, okay, this is going to generate a bunch of digital data. And it's not just about maintaining and using that data effectively, it's actually leveraging it to do new science. And it was the very first time I saw the synergy between experiment and computation within biology, at least. And so that notion really got to the point where people got really excited. And then as the genome was becoming realized, industry suddenly realized, wow, there's a huge future here. They basically bought up a whole bunch of the computational biologists. And then, unfortunately, the timeframes with which it was necessary to see the advances that computational biology was going to bring was not in alignment with the short product cycles that industry has. So a lot of those people drifted back to academia. But I'd say over the period of like the 2000s and then into 2010 and beyond, it became to the point where you could get a tenured position by doing just computation in biology. So it really exploded. Um, and then essentially what happened after that is it just became to the point of being an very well accepted path. And I would say to the point where, in a way, where it was sort of a support mechanism for experiment. I say the opposite is now true, that the predictive modeling that is and will continue to come from the computational study is going to drive what we do experimentally. The experiment becomes essentially a validation of a computational outcome. That is a fundamental reversal. And I said exactly that what I just described to you to the advisory board of the director of NIH when I was actually at NIH and reported to the director. And no one, my time frame was a bit off. I said 2020. It's now 2022, and we're still not really there, but we're close. And it's going to be profound. And that is something. And so what drove that? Well, initially it was all this digital data that got everybody, got the juices flowing and the compute cycles going, and everything happened from there. That's now happening in every conceivable discipline. And I would say, sitting here in academia, in the 40 years I've been in it, there's nothing going on like what's going on now across all of these disciplines. And as I said already, the goal here is to try and use our school to, cross-purpose a lot of the innovation that's happening across the different disciplines. So that's really the relationship. And I'm now doing it in my own field of which I now call, of course, biomedical data sciences is what we're calling it now. But it's going on in all these other disciplines as well.
Nice. So to recap what you said there and paraphrase back to you, from the 80s until the early 2000s, there were only weirdos like you using computers to analyze biological data, and it was a little bit niche. But then starting around 2010, people driven by things like the Human Genome Project and people seeing the value in all of this digital data, people could start to get jobs around 2010 doing computation alone in not only biology, your field, but in other disciplines as well. So the same kind of digitization that we see in biology exemplified by, say, the Human Genome Project, we're seeing this kind of digitization in a lot of different traditional academic disciplines. And that spans not only the sciences, but the arts as well. We see things like when I was an undergrad, I don't think there were any faculty at my university who were like computational historians. But now lots of people are analyzing digital records, analyzing literature, using natural language processing techniques. And I suspect that, similar to what you're describing in biology, whether it's the sciences or the arts, the humanities, people are, a decade ago, people started being able to have their job be focused entirely on applying computational methods to whatever digital data you could get in that discipline. And now what you're saying is that in recent years, and a trend that will no doubt continue in the years to come, these digital records and computational techniques aren't they're not the result of trying to think about solving some problem. They actually drive even what problems should be solved, what experiments should be run.
Yeah, no, that's great. You were actually listening to what I said. I'm impressed. But you did you did remind me that just a little story that really got this sort of thing going. And really, it sort of goes back to why I'm so keen on doing this school. Is when I was at UC San Diego for many years, and at one point I became the associate vice chancellor for innovation and industrial alliances, which took me out of my pharmacology department and took me around the campus to talk to all sorts of different people to try and help them, turn their research ideas into product. And I went to see a fellow in the Rady School of Business. And when I walked in there, he had a paper of mine on his desk from computational biology. And I
A
said, "Oh,
paper
you
mine?
knew?" I'm sorry,
A paper mine?
no, a paper of
Oh,
mine.
a paper of yours. Sorry, I don't
It's
know. Yeah,
it's
I
my Virginia accent.
yes.
And I said, "Oh, you brought that paper out because you knew I was coming to visit you." And he said, "No, I had no idea it was your paper. We're using a statistical method from this paper."
Mm.
So, here is. I said, "What are you using it for?" He said, "We're analyzing Corning marketing data." And I said, "My God, it's completely different than what I was doing with that method." And that got us talking. And it was all about the time, this was like 2010, 12, when big data was just becoming, a thing. So
Mm.
we got talking and we ended up organizing a big data at UCSD Day. And it was the most attended event, I think, as I recall being told, by faculty in the university's history, because they
Wow.
all smelt money. They smelt what was coming.
Right.
And it was full of the kind of things you just alluded to. The one I particularly remember was someone talked about where in the world is Francis Bacon, and it just so essentially what they'd done is they'd done natural language processing on a whole set of digital texts, historical texts that included references to Francis Bacon, and they built a social network of Francis Bacon, where he was on a certain day and time, who he talked to or he communicated with. And I thought to myself, however accurate it might be, it is a tool that's going to change how we study history. No one's going to sit there pouring through massive amounts of text in Latin and goodness knows what else ever again, because there'll be, that will be the fallback position. Well, we'll accelerate the way we study history. And I thought, well, that's just one field. That's just
Mhm.
happening everywhere. And now I've got all these people doing digital humanities in the school, doing really interesting stuff that is completely alien to me as a researcher, but incredibly interesting.
Did they pick Francis Bacon because of the 6 degrees of Kevin Bacon?
No, I don't think so. But I guess they were just scholars that were interested. Somehow got hooked up with these computing geeks, who really helped them and opened their eyes to all of this. Yeah, but yes, it's a good question.